In this activity, we're going to use the laser rangefinder sensor to make a simple laser ruler. For information about this activity, use the TMT code below the title. And for information about the laser rangefinder, use the TMT code at the bottom of the screen. And to do that, you just go to jb.works and type the TMT code in at the search prompt. And remember, the TMT codes are all case sensitive. Now here we can see the program running, and if you look on the left hand side, we've got a scale which goes from 0 meters to 2 meters, and then this indicator. So as I lift the JackBord up, you can see the distance increasing, and then I put it down again, and so this is an electronic ruler. And then if I put my hand in front and I move it away, so we're using the show page to give us a graphical representation of the ruler value. So now let's see what we need to get this done. These are some of the resources that will help you with this video. The first one is some general information about the laser rangefinder USI, and you can get to that just by using the TMT code shown to the right. And then the next one is the video, which shows you how to connect the sensor to the JackBord. And again, just use the TMT code on the right and you'll be taken straight to that video. Okay, you're going to need a charged JackBord, 4 short female to female jumper wires, 1 laser rangefinder USI, 1 M4 bolt, M4 nut, spanner of some sort, and an Allen key. Basically, the procedure for putting it together is the same as for the other video. So first of all, because the sensor uses the I2C port, we need to put the bolt down there and we'll attach the sensor down there. So just put the nut on top. And we tighten it up. Then the next one is a green jumper wire for the ground from the sensor. And also make sure the JackBord is turned off while you're doing these connections. Then we go for the yellow for 3 volts because the sensor likes 3 volts and it goes into the 3 volt pin on port D. Next, we're going to use a white jumper to go to the serial data, which is the white pin on the USI that's next to the ground pin. And that goes over to pin D5 on the JackBord, which is also marked as the SDA pin for I2C, which stands for serial data. And then finally, we need the clock pin, which goes from the blue pin on the USI into the corresponding blue pin on port D, which is D4, and that's the SCL pin. So essentially that's the sensor connected, and the actual sensor is on this side, so it's detecting this way. Here are some pictures you can use to check that your connections are okay. Compare yours with these and make sure that they match. And pay particular attention to the fact that the blue wire goes to the blue pin and the white wire goes to the white pin. You don't have to use exactly the same colors as I have, but it helps. Next, we need the program that will run our simple ruler. To get the code, simply visit jb.works and type in the TMT code below at the search prompt and you'll be taken direct to the code. When you get there, copy it into one of your free program slots on the dashboard on the program page. We've loaded the program code for the laser ruler into, in our case, program slot 7. So just before we run it, we will have a quick look at the code. So first of all, we've got 2 program variables. One is y_pos, and that's going to be the vertical position of the marker on our scale. And then the value _ypos is the vertical position on the scale of the text reading from the sensor. Next, we clear the screen, and we're using the show page for this program. You can see over here. And then we add a title, we add the quit button, so PB is put button, PTL is put text line, because we're just putting one line. And then this PVL command, which says put vertical line, is making the y-axis of our graph, of our ruler rather. And then of course the ruler needs graduations, and that's what these are. So you can see you've got 2 meters here, 1.5, 1 meter, half a meter, and then 0 meters. And these appear on the left-hand side. Then we find the sensor, wait a while, and then we come down to the main program loop, and this is where the program spends most of its time. So the first thing we're doing here is we need to scale the distance from the sensor, which will be between 0 and 2000 millimeters, to the length and position of our ruler axis. So the top of the ruler is at 100, the bottom is at 300. We want the maximum reading from the sensor to appear at the top of the ruler and the minimum reading to appear at the bottom of the ruler. And that's what this lot does. And it works on the live reading from the laser distance meter. And that value gets pushed into the ypos variable. And the next thing we do on this line is we go put horizontal line, and we use that value of ypos that we calculated up here, and we basically make the line width 4, we make the line color green, and we give it an ID. And what this means is that because we run this over and over again, by giving this particular line an ID, instead of drawing a new line every time in a different position, we'll actually update the existing line. Then down here, this is where we display the numerical value next to the marker. And because of the way the text display works, we need to adjust the position of the text basically by subtracting 25 by the value of ypos, from the value of ypos. And we end up with this value, which is the value ypos. And then we use the put text line. The X position will always be 80, but the Y position now varies up and down according to the distance. And then this is the text that we display. And then finally we wait quarter of a second, and then we do the whole lot again. So let's run the program and we'll see it operating. So you can see you've got the graduations on the scale. There's our moving value, and if I lift the JackBord up, you can see the marker moves and the numbers move with it. And so in theory, a 0 reading from the sensor should correspond to roughly the bottom of the value, the bottom of the scale, and then a maximum should go right up to the top. Or in our case, I say 1 meter. So essentially you've got an electronic ruler that is indicating the distance detected by the laser rangefinder sensor. And you can use this for all sorts of things, like a short range ruler. If you added a wee display to it, you could do that. And it's also useful for things like a driving robot, whereby you want to be able to detect objects in front of the robot and how far away they are. And finally, when you're finished with the program, you just click the quit button and it will stop operating. For more information, visit jb.works.